different types of addressing modes, and this applies to instruction code. Okay, so this is the instruction code. In instruction code there are different fields. This first field is the mode, the second medium field is the opcode, and the last field is the address part. Opcode specifies the instructions such as add, multiply, subtract. All these instructions will be there, and the mode specifies how this address part will be accessed. This is the part of the mode. Now there are some advantages associated with it. It gives versatility and flexibility to programmers, which means the way in which this address is accessed, it gives more options to the programmer to write the program more efficiently and make the program more faster and better. And also one more advantage is to reduce the number of bits in the address field, uh, which means if we use different mode, then with that other mode we may be able to use less number of bits and then have it perform the exact same operation with less number of bits. So these two are the main advantages of using different addressing modes. So now let's look at the different types of addressing modes one by one. Normally there are 10 different addressing modes. Now let's look at them. The different types are implied mode. In implied mode, the instruction code in implied mode, the address part is not required because it is by default implied in that. For example, in accumulator operations such as CMA complement A, here we know that the accumulator AC, the accumulator register, needs to be complemented. So no address is required. Directly it will work without the address part. So this is the implied. It is implicitly implied. No need to explicitly give an address. So that's it. So the next is immediate mode. In immediate mode, in this address part, the operand such as add 5, the 5 is the direct value of the operand. So the value of the operand is directly in the instruction code. So that is immediate mode. Immediate mode, it is directly in the address part. In register mode, there is a computer register, the operand. In the address part, the register will be specified where in the register such as R1, it will be stored the value of the operand such as add and the address of the register, and if 8 is there in R1, from this register we'll get the value of the operand. In register indirect mode, this value where the register was there, it is almost similar, but this is actually the address of whatever will be there. Suppose 803, this is actually the address of the operand. In this address we will find the value of the operand. This is register indirect mode. And then auto increment or decrement mode. In auto increment or decrement mode, it is exactly same as register indirect mode, but in auto increment mode the register is incremented, which means if it was 803, it will be 804, first, and then yes, whenever after we access the value of the operand from this address, the register will be incremented to 804. This is it. And next is auto decrement mode. In this mode, the value of the register R1 is decremented. It will be made 802. It will be 802, and then the operand will be accessed from this address. And there are 5 more other types. Let's look at them. It is the 6th number is direct address mode. In direct address mode, the address part contains the address of the operand. It contains the address of the operand. That is in itself the direct address mode. Nothing too complex, it's simple. It directly contains the address of the operand in the address part. This is direct address mode. In indirect address mode, whatever address will be there here, whatever address will be there in that address, suppose if it is 800, in that address we will find the address of the operand. This is indirect, that's why it's called indirect. In indexed addressing mode, there is an index register. Suppose Rx, in this index register there will be some particular value like 40 or any value will be there. And whatever the address will be specified in this instruction code, this address will be added with the value of this Rx. So it will be 840. So 840, in this address we'll find the value of the operand. Then the next is base register addressing mode. In base register addressing mode, this is, I mean, the concept of this is same with index addressing mode. Here there is a base register BR, base register will be there. This will also have some particular value, 30, 40, whatever particular value will be there, and the value what we specify in this instruction code, it will be added with the value of the base register, and from this value, here in this case it will be 830. From this value we can get the value of the operand. And the last one is relative addressing mode. In this relative addressing mode, whatever value we specify in the address will be added with the value of the PC, which is program counter. Program counter stores the value of the next instruction. In this program counter, what will be the yes, whatever value is there in the program counter, suppose 202 will be added with 800, which is equals to 1002. So from 1002 we will get the value of the operand. Now let's look at the examples. We have one example of table where we have to find the addresses, which will make us easier to understand. These are the addressing modes. They are direct, immediate, indirect, relative, index, register, register indirect, auto increment, and auto decrement. Okay, and this is the memory. This may be RAM. In this RAM, where all the instructions and the programs are stored, and these are computer registers. All the computer registers inside the CPU, all the registers is a program counter. This is a computer register inside the CPU, and this is the program counter. This is indexed register. This is the accumulator. Accumulator is the default register. So now let's come on, let's look at from direct address. Okay, this is the instruction part first. Let me explain this first. This is the instruction part, and this is the instruction load to AC, which is this AC. Right now this AC value is empty, so to this AC we have to load a value. So this is the instruction, and this is the address part. Whatever value we have to load, this is the address part. So now, since we are talking about addressing mode, now this is the mode. This mode will tell us, these all modes are there. This mode will tell us the meaning of this address. This address has right now no particular meaning. We cannot directly go to 500. Different modes have different meanings. So let's start with direct address. In direct address, as we know, whatever address is given here will be the address of the operand. Which means in direct address the address is 500, so we have to go to 500. So the effective address means the address of the operand. In effective address, direct, it will be 500. Effective address is 500, and what we get the value here, content of AC is 800. Here we get the content of value as 800. So 800 will be loaded to AC in case of direct address. Now in case of immediate operand, whatever value is there in the address part is directly the address part. So what we have to do here is effective address. Okay, immediate operand, the operand is 500. The effective address will be 201 because the operand is found at this position and the address is 201. Immediate is 201 and the content of AC will be 500 because the 500 is loaded to this. Then indirect addressing. In indirect address, whatever address we find here, first we have to go to this address 500, and there we again find another address that is 800, and then in 800 we find the actual operand. So it contains the address where the address of the operand is found. So address of the operand is 800, which is the effective address, and then the operand value is 300. Now relative address. In relative address, what we have to do is whatever value is there in 500, we have to add it with the value of the program counter. Program counter's value is actually 202. This was the value before the instruction was executed. After execution is 202. 202 plus 500 we have to add in relative address, so it will be 702. So in this we will find the operand. 702 is the effective address, and the value is 325. 325 will be loaded to AC. Now in index address, what we'll do is whatever address is there, we'll add it to the index register. This is index this is index register. It is 100, so 500 plus 100 is 600. 500 plus 100 is 600, so in 600 we find the operand 900, and 600 is the value. Then the value is 900. Then in register mode, so what is the register mode? So in the register mode, you have to look into the computer register. Okay, in the computer register there is no effective address, so we give a dash, and then the value is 400. In register indirect, whatever is there in this computer register, this will be the address of the operand. This will not be the actual operand, but this will be the address of the operand. So the address of the operand is 400, and the thing is, so what is the value? The value is 700. Content of SC will be 700. So in auto increment, what we have to do? In auto increment, we have to do the same as register indirect, which means first we have to go to this, and then from 400 we can find the 700 value. 400 is the address of this operand, and 700 is the value of this. So this is, after doing this, it increments the value of R1, right? It increments the value of R1. 400 will become 401, right? Okay. Then what is auto decrement? In auto decrement, first we'll decrement the value of R1, which means 400 will become 399, and now it will be the value of the, address part of the operand, which is 399, which is 450. So this is it. So let's recap. These are the different types of addressing mode. These are the advantages. It's the instruction code. Mode controls what type the address will work. Okay. Then the types is implied mode. Yeah, implied is there. Immediate, and register mode, register indirect, auto increment, decrement. How this all works. Then this is direct address. This is indirect address. Okay. And look, this is yes, index addressing mode. We have also discussed about this. Okay. Then base register addressing mode, then relative addressing mode. If you have not if you have not understood it, you can look back the video, and this is the example. This is a very good example to understand. If you have not understood it, watch it again.